Every single person you love will die. That's obvious, right? But here's what keeps me up at night. Every human who has ever lived, every civilization we've ever built, every book ever written, every song ever sung, every memory of humanity's entire existence will be completely erased. Not by war, not by some cosmic accident, but by the star that gives us life. The sun is going to destroy everything, and despite all our technology, all our scientific progress, we have absolutely no realistic way to prevent it or escape it. Now, before you click away thinking this is just some doomer content, stay with me. Because understanding how the sun will die and why we're essentially trapped teaches us something profound about our place in the universe and what it really means to be human on this tiny rock orbiting a middle-aged star. Plus, the physics of stellar death is genuinely fascinating once you see past the horror of it all. Let me take you through what's actually going to happen. Not in some vague, hand-wavy way, but the real sequence of events that scientists have mapped out with frightening precision. The sun has been burning for about 4.5 billion years. Right now, deep in its core, hydrogen atoms are being crushed together under unimaginable pressure and temperature, fusing into helium and releasing energy. That's what makes the sun shine. That's what keeps us alive. But here's the thing about fusion, it's messy. Every second, the sun converts roughly 600 million tons of hydrogen into helium. And slowly, very slowly, the core is filling up with helium ash. Think of it like a wood fire that's gradually being buried in its own ashes. For now, everything seems stable and predictable. The sun is in what astronomers call the main sequence phase, which is just a fancy way of saying it's stable. The outward pressure from fusion perfectly balances the inward pull of gravity. It's been this way for billions of years, and it'll stay this way for about another 5 billion years. But that balance won't last forever. As more helium accumulates in the core, something strange starts to happen. The hydrogen fusion moves outward into a shell around the dead helium core. And when fusion happens in a shell instead of a concentrated core, the star becomes unstable. The sun will start to brighten. Not gradually or gently, but substantially and dramatically. Over the next billion years, the sun's luminosity will increase by about 10%. That might not sound like much, but remember we're talking about the entire output of a star. That extra 10% will be enough to trigger a runaway greenhouse effect on Earth. The oceans will start to evaporate. Water vapor is a greenhouse gas, so more water vapor means more heating, which means more evaporation. You see where this goes? Within a billion years, maybe less, Earth will look like Venus. A scorched hellscape with surface temperatures hot enough to melt lead and an atmosphere so thick with steam and carbon dioxide that no complex life could possibly survive. And this is just the beginning. The sun hasn't even left the main sequence yet. But wait, you might be thinking, a billion years is a long time. Surely humanity can figure something out by then, right? We went from the Wright brothers to landing on the moon in just 66 years. What could we accomplish in a billion? And that's a fair point, which is why we need to talk about whether escape is actually possible. Because the answer might surprise you. Before we get to that, though, let me finish the story of what happens to the sun. Because it gets so much worse. After about 5 billion years from now, the helium core will have grown massive and dense. The temperature will climb high enough that helium itself starts to fuse, combining into carbon and oxygen. When this ignition happens, it doesn't happen smoothly. There's a phenomenon called the helium flash where the entire core ignites almost simultaneously in a burst of fusion that releases as much energy as an entire galaxy. The sun doesn't explode from this, because most of that energy goes into heating the core rather than blowing the star apart, but it marks the beginning of the red giant phase. This is where things get truly apocalyptic. The sun will expand. And when I say expand, I mean it will swell to roughly 200 times its current diameter. The outer layers will cool and glow red, which is why we call it a red giant. But from Earth's perspective, if Earth still exists at this point, the sun will dominate the entire sky. Current models suggest the sun's outer atmosphere will extend somewhere between 93 million miles and 108 million miles from its center. Earth orbits at about 93 million miles. The implications are terrifying. There's some debate among astronomers about whether Earth will actually be consumed by the sun's outer layers or whether it'll barely escape. As the sun loses mass, Earth's orbit will spiral slightly outward. But even if Earth technically avoids being swallowed, it won't matter. Anything on the surface will have been vaporized long before the sun's atmosphere reaches us. The temperature will be thousands of degrees. The planet will literally melt. Continents will become seas of molten rock. The atmosphere will be stripped away. Earth will be reduced to a charred cinder orbiting inside the swollen red giant. And then, after burning through its helium for a few 100 million years, the sun will die. It doesn't have enough mass to go supernova, which in a weird way is almost disappointing. Instead, it will shed its outer layers in a series of pulses, creating what's called a planetary nebula. That's a bit of a misnomer, by the way, because it has nothing to do with planets. Early astronomers just thought they looked planet-like through their telescopes. The core will collapse into a white dwarf, a dense ember about the size of Earth but containing roughly half the sun's mass. And it will sit there, gradually cooling, for trillions of years. The solar system as we know it will be gone. Mercury, Venus, probably Earth, possibly even Mars, all consumed or destroyed. The outer planets might survive as frozen worlds orbiting a dying ember. And any trace that humanity ever existed will have been erased millions of years earlier. Now here's where we need to have an uncomfortable conversation about escape. Because I've seen countless science fiction stories about humanity fleeing a dying Earth, colonizing other star systems, becoming a spacefaring civilization that outlives our sun. And look, I love that optimism. But we need to be realistic about the physics involved. Let's start with the most obvious solution. We could simply abandon Earth entirely. Build generation ships, send humans to other star systems, establish colonies around younger stars. Problem solved, right? Except the distances involved are almost incomprehensible. The nearest star to the Sun is Proxima Centauri, about 4.25 light-years away. That's roughly 25 trillion miles. With our current fastest spacecraft, it would take tens of thousands of years to get there. And that's just the nearest star. You might say, well, we'll develop faster propulsion. Maybe fusion rockets, maybe antimatter drives, maybe something we haven't even thought of yet. And sure, that's theoretically possible with enough time and resources. But even if we could somehow reach 10% the speed of light, which would require technology that seems almost magical from our current perspective, we're still talking about 40 years to reach the nearest neighboring star. And we'd need to bring everything with us. Food production, water recycling, power generation, genetic diversity to prevent inbreeding, the knowledge and tools to build an entire civilization from scratch. We're not talking about a few hundred people in a tin can. We're talking about essentially moving a small nation through interstellar space. And here's the thing that really gets me. Even if we could do this, even if we could build these incredible generation ships and send thousands or millions of people to other stars, we're not saving humanity. We're saving a fragment of humanity. The vast majority of people would be left behind. Because there's no conceivable way to evacuate 8 billion people, let alone the hundreds of billions or trillions who might exist in the distant future. The ships would be expensive beyond comprehension. Every launch would require resources equivalent to entire nations. You'd be looking at saving maybe a few million people out of billions. And who decides who goes? Who gets left behind to die as Earth becomes uninhabitable? But let's say we're being optimistic. Let's say we don't try to evacuate everyone, we just try to preserve the species. Send enough people to establish viable colonies elsewhere. Bring along our accumulated knowledge, our art, our history. Keep some version of humanity alive even if most of us die. That's still a monumental challenge, but at least it's theoretically possible. Except there's another problem. Time itself works against us. Remember, we have about 1 billion years before Earth becomes uninhabitable and about 5 billion before the Sun enters its red giant phase. 1 billion years sounds like forever, but think about how long humans have existed. Anatomically modern humans appeared roughly 300,000 years ago. Civilization began maybe 10,000 years ago. We've had advanced technology for barely a century. A billion years is more than 3,000 times longer than humans have existed. What are the odds that anything resembling current humanity will still be around in a billion years? Species evolve. Civilizations rise and fall. The human descendants who live a billion years from now, if any exist, will be so different from us that we might not even recognize them as human. They might have uploaded themselves into machines. They might have merged with artificial intelligence. They might have genetically engineered themselves into something unrecognizable. Or, and this is probably most likely, they might have gone extinct long before the sun becomes a threat. Most species last only a few million years before they either evolve into something else or die out. Humans are not special in this regard. This is what I find both terrifying and strangely comforting about the sun's death. It puts our existence into perspective. All our worries, our conflicts, our struggles for power and resources, they're all happening on a stage that will eventually burn. Nothing we build will last. No monument, no city, no empire will survive the red giant phase. We like to think of ourselves as permanent, as the culmination of evolution, as the species that conquered the planet. But we're just temporary custodians of a doomed world. Some people have proposed more radical solutions. What if we could move Earth itself? There's a concept in planetary engineering called a stellar engine. The idea is to build enormous mirrors or use the sun's own energy to create a thrust that gradually changes its trajectory through the galaxy. If we could do this, we could theoretically keep Earth in a habitable orbit even as the sun ages. But the engineering challenges are absurd. We're talking about moving an entire planet over billions of years using technology that doesn't exist and might not be physically possible. And even if we could do it, we're just delaying the inevitable. Eventually, the sun will die, and we'd need somewhere else to go anyway. Or here's another idea. What if we could trigger fusion ourselves? Build artificial suns, miniature stars that we control. Live in massive space habitats powered by fusion reactors, completely independent of any natural star. This is theoretically possible. We're already working on fusion technology, and while we haven't achieved sustained fusion yet, it's not science fiction. It's engineering. Given enough time, we'll probably figure it out. But again, we're talking about moving billions of people into space habitats and maintaining that civilization for billions of years. The logistics are mind-boggling. And there's a deeper philosophical question here. Should we even try? Is the goal of humanity to survive forever, to spread throughout the galaxy, to outlive our star? Or is there something beautiful about being finite, about knowing that everything we do is temporary? Some philosophers argue that death gives life meaning, that the fact that we're going to die, both individually and as a species and as a planet, makes what we do right now matter more, not less. I don't have an answer to that. Part of me wants humanity to survive, to establish colonies around distant stars, to become a true spacefaring civilization that outlasts the sun. Part of me thinks that's hubris. The universe doesn't care about us. Stars are born and stars die, and we just happen to exist during this particular star's middle age. Trying to fight against that might be noble or it might be futile. But here's what I do know. Right now, in this moment, we're alive. We're conscious beings on a planet orbiting a stable star in the habitable zone. We have maybe 1 billion years before things start to go wrong, and 5 billion before the sun enters its red giant phase. That's an incomprehensibly long time by human standards. Entire evolutionary branches could rise and fall. New forms of consciousness might emerge. Technology might advance to levels we can't even imagine. Or maybe we'll destroy ourselves long before the sun gets a chance to. Climate change, nuclear war, artificial intelligence gone wrong, a pandemic worse than anything we've seen, there are plenty of ways humanity could end in the next few centuries, let alone the next billion years. In a weird way, worrying about the sun dying is almost optimistic. It assumes we'll still be around in 1 billion years. It assumes we'll have solved all our immediate problems and can focus on these cosmic scale challenges. The sun's eventual death is inevitable. We can't stop it. We probably can't escape it, at least not in any way that preserves what we think of as humanity. And maybe that's okay. Maybe the point isn't to last forever. Maybe the point is to do something meaningful with the time we have. To explore, to create, to love, to understand as much as we can about this strange universe we find ourselves in. 5 billion years from now, the sun will be a red giant. Earth will be gone. Any trace of human civilization will have vanished. But right now, today we're here. We can look up at the sun and understand what it is, how it works, and how it will die. We can contemplate our own extinction on a cosmic scale. That's pretty remarkable when you think about it. We're temporary patterns of matter that have become complex enough to understand our own temporariness. So here's my question for you, and I really want to know what you think. If you knew for certain that humanity would be extinct in 1,000,000 years, regardless of what we do, would that change how you live your life right now? Would it make anything you do seem less important? Or would it make the present moment more precious? Drop your thoughts in the comments, because I genuinely find this fascinating. We're all stuck on this rock together, orbiting a dying star, trying to make sense of our brief existence. Might as well talk about it.